Okay, so the problem we will be solving will be to design a hit counter. So we are given that design a hit counter which counts the number of hits received in the past 5 minutes, that is the past 300 seconds. Okay. Your system should accept a timestamp parameter in seconds granularity. Okay. And you may assume that calls are being made to the system in chronological order. Okay. That is timestamp is monotonically increasing. Okay. So we will not have a timestamp which is basically you should accept a timestamp parameter. You may assume that calls are being made to the system in chronological order. So, okay, so there cannot be a call which is, let's say, time equal to 20 seconds and then there is a call at time equal to 10 seconds. Each call will have a successively increasing timestamp. Several hits may arrive roughly at the same time. Okay, so that means that for, let's say, time t equal to timestamp second, there can be several hits. Implement the hit counter class. Hit counter initializes the object of the hit counter system. Okay, void hit records a hit that happened at timestamp. Several hits may happen at the same timestamp. That is okay. Get hits. Return the number of hits in the past 5 minutes from timestamp. Okay. Let's go through an example. Hit counter. Okay, so that initializes all our object. This is basically the constructor. Okay, then you have a hit which is a hit at timestamp of 1. Okay, 1 is the input here. Hit at timestamp of 2, hit at timestamp of 3. Get hits 4. What is okay, get hits at timestamp 4, that is you return 3. Then you hit at timestamp 300. Okay, then get hits at timestamp 300, that means that you will get all 4. Then get hits at timestamp 301, you will get only 1. No, you will get 3, right? Only the timestamp 1 will be. So we can observe that this is similar to rate limiter kind of thing. Rate limiter with a sliding window with a queue. So we will only have all the hits that are made between the past, let's say, 5 minutes or so. Okay. On the calls are being system in a chronological order. It is timestamp is monotonically increasing. Okay. Not strictly increasing, but increasing. Okay, so it can be same, right? Timestamps can be 1 or 2 into 10 raised to power 9. So that means it will be in range. Okay. At most 300 calls will be made to integrate it. Okay. What is the number of hits per second could be used as your design scale? Okay. So the question is, we essentially in that data structure that takes care of removing all the elements before particular and we use a data for. Okay, so basically whenever we do hit, we don't really care about what element there in the DQ. So we will do DQ dot push back timestamp. Okay. Here, firstly, we'll have to check if the timestamp in front of the queue are expired. If yes, we need it. So, okay. So let's say any expiry time equal to timestamp minus 300. So, for example, if timestamp is actually at 200, then so if the timestamp is at 100, if it is at 200, so will the value is 0. Okay. Now if DQ is empty, then there is nothing we can do. While DQ is not empty, and let's say DQ dot front, let's say is either less than or equal to, also if there is less than or equal to expiry time, basically if the timestamp is 301, so if it is less than 1, then we can just DQ dot pop. Then once we return, let us say DQ becomes empty, then also we have no problem. If DQ does not become empty, then also we do not have a problem. And yeah, so we will here give to the size. So now, before moving on, let us just revise what are the operations of DQ. Just say DQ operations C++. Okay, so this is pushback is there. Okay, then we have insert, or we can insert anywhere in the DQ, right? We don't really want that. Position for slash other, we don't really want that. And place front and place back. Yeah, front gives us returns an element. Okay, returns a reference to the last element. Okay, back, pop front, pop back. push front and push back. Pop front, pop back, push back, empty and size. Give operations with their complexities. Okay. So okay, yeah, axis in front, back is O1, then at index is also one because I think this is an array-based implementation. Push front is O1, push back is O1, pop front, pop back is O1. So we'll not care about. Okay, fine. So I will just write it as a comment here. What are the DQ operations? Front, back. The few operations which are actually useful. Those are then you have push back, you have push front, and you also have pop back, and you have pop front. Okay, all of these are overflow operations. So okay. So what I will do is vq.front is less than equal to, so I will do vq.pop front, keep doing it, and then I will return vq.size. Okay, size vq will be there, and I think we have to undeclared identified vq. How come did that happen? That happened because I was in a hole. So firstly I'll have to define the private variable q. No, right, I do not need to. Not it as a private variable. I put it as a public variable. Private will also work because then these functions can only access this variable. So private is also. So we basically do not need any initialization. Okay, so case 1 is running fine. Let's see. Okay, so this is accepted. Now, all the calls we make to the system in chronological order. What if hits per second could be huge? Does your design scale? So if hits per second are huge, does your design scale? So let's try to see what is the problem if hits per second are large. So if we have many hits which are at the same timestamp, then how do you make sure that your hits are actually getting in the queue? So if one problem is that the size of the queue can become very large, right? So in that case, what you can do is that so we do not want to use a lot of memory. So that use of little less memory will come with a trade-off of time complexity. So if there are, let's say, 10 hits that happen at one timestamp, we can just store not the timestamp, but let's say all the hits that were there at the timestamp. So number of hits, comma timestamp. And then whenever there is a get hits record, we delete all the previous hits and then we count till the current timestamp how many total hits are there. Or we can maybe create a counter, right? Yeah. So we can create a counter that keeps a count of all the hits till now. Yeah, logger rate limiter. Rate limiter is also kind of a similar question. So yeah, if the number of hits are large, our current design does not scale. So let us say there are 2000 hits at a timestamp. So at that timestamp, we will have to have a lot of memory, and whenever we will get a get hits, we will have to use a lot of time to remove all those hits. So instead of that, what we can do is we can keep a counter, right? That will keep the number of hits till now. Now for a particular timestamp, let's say time t equal to 0, we got 10 hits. So we'll save 10 comma 0, then 20 hits for 1. So and the counter would be 10, then 30, and so on. Then let's say we are asked that timestamp equal to 2, what are the number of minutes? So we say, okay, everything is less than 5 minutes, so what is count? Give it. It's giving it. So we keep a number there. Okay, so that was our solution. Let us see what the editor says. So it is using Q. Yeah, why did you use a loop here? Q would have worked just fine, right? Entry is just this side, exit is just this side. So push back, just push. Yeah. Okay. मतलब if you are saying कि memory constraints नहीं है मुझे and I don't want to delete anything, in that case what I can do is that I can have the expiry time and then I search the uh, whatever the expiry time timestamp is in the key, and I get the number of hits. But anyway, to do that also, then I have to traverse the total, subtract the total. Okay, nice question from